How you doing?
Pretty good. How are you?
Not too bad. I'm just eating. I figured I'd stop in and see what the conversation was.
Yeah, we were just talking about how truth is a process that unfolds over time, trying to discover it.
I agree.
So I got a question. I've never been given like an actual argument that's pro flat Earth from anyone. I guess I'm sheltered in that way. Could anyone give me like a convincing theory as to why that's the case, or the flat Earth is?
Yeah. I mean, I can give you a short version. I'm kind of tired, and then maybe somebody else wants to jump in. But basically, the thing that convinced me originally was several different books I read, and chapters in particular in those books that talked about the geometry of the Earth and specifically what we would see in the distance if we lived on a ball, a sphere, as is claimed. And we would, if we lived on a sphere, there's many things that we can see that we would not be able to see if we lived on a sphere. For example, I live in Southwest Michigan, and over on the Lake Michigan shore, when you go over to Warren Dunes, Sawyer area, south of Benton Harbor, there's a lot of beaches there where if you look across to Chicago, you can see the skyline. It's common knowledge in the area that you can see the skyline. It's like if you look at, we can show you some images of what it looks like when people use high-powered zoom cameras, but even without that, you can see like the outline of all the buildings. They play taps on the beach at sunset over there every night, and sometimes the taps on the beach, you can see Chicago, and everybody's just like, oh yeah, there's Chicago. But if you look into it, if we really had the curvature claimed, Chicago would be behind the curvature, and you would only see the very tips of the building. But in fact, we can see most of the buildings depending on atmospheric conditions much more than we should see. I mean, that's the main argument that convinced me. Then I looked into the math. The rate that's given is that these objects are dropping off in the distance at the rate of 8 inches per mile squared, which, because it's exponential growth of the amount, it quickly becomes very large and measurable to the point where at 10 miles, objects would be hidden behind 66 feet of curvature and so on. Does that make sense?
Yeah, I see what you're saying. I think, well, for obviously a massive city like Chicago, those buildings are going to be very tall. And so, I mean, you from Michigan, you can't, or wherever you were saying that you were looking, you can't see the bottom of the building, but you can see the top of the building. And so
you shouldn't be seeing the amount that we're seeing. You should only be seeing the top. Doesn't matter if you can see the bottom or not. There's a lot of things that would cause that to happen.
Why can't you see the bottom?
Atmospheric conditions, water conditions. There's many reasons you might not be able to see the bottom. Sometimes you can see the bottom. Things don't always look the same every day. Like I just told you don't even see it every day. You just see it some days.
Yeah, I know. But if you're at the same point, you should be able to see the same amount, if that makes sense. So if the atmosphere changes, one day it's cloudy, a lot of moisture in the air, and you can't see as far, you can't see the buildings, right? Next day it's clear. You can see, let's say, 100 feet to the top of the building. Let's just use that as an example, right? That shouldn't change, basically. That 100 feet is always going to be there from this same point, as long as you don't move forward or backwards. So if it's foggy and you can't see the building, that 100 feet is still going to be there. You just can't see it. But if the cloud blows
We're not talking about 100 feet. I don't know what you're talking about.
Yeah,
you see 27 minutes after the hour where Miguel Sousa has put in the 56 miles line of sight, the physical, tangible city of Chicago, not a mirage, 2,000 plus feet of missing curvature. So I don't know what you're talking about. We're talking about you should only see the top of the buildings, and you see way more than that. It doesn't matter what's on the bottom.
I'm not talking about the bottom. So I'm saying is the amount that you can see is not going to change. So for instance, I used to live across from Seattle, and every time we would go up this one road, we would see the tops of the buildings from Seattle, even the Space Needle, right? And but the amount of the buildings we ever see, if we could see like the top 300 feet of the Space Needle, which is about 900 feet tall, we would never be able to go up there on a day and see 500 feet of the Space Needle. We would only see that same 300 feet, no matter what day, no matter how warm it was, no matter how hot or dry it was. We would only see that same 300 feet.
What's your point? I'm not talking about the Space Needle. You asked me what convinced me. Are you seriously telling me you just came in here and you haven't heard about anything about flat Earth before? Are you sticking to that story, V6? Because I thought we were having a serious conversation, but you want to jump from Chicago to Seattle, and I'm still in Chicago. So, did you look at Miguel's image there?
I'm using an example from my.
Okay, so explain to me where's the 2,000 feet of missing curvature in Chicago then?
Oh, I don't believe that there is such a thing. So
you believe in fairy tales. You prefer the fairy tale globe, and you prefer to stay in the comfortable reality of, the comfortable non-reality of mainstream society because that's easier for you. And you're just going to make up whatever story. And if I tell you what's actually seen, measured, observed, and documented multiple times, you're going to tell me you don't believe in it because you believe in the ball. I understand. That's your religion, and you want to stick to it.
Politely for a long time, but then you wouldn't even let me finish my thoughts. So
because I think you're disingenuous. So does anybody else want to talk to this guy?
Oh, I don't need. I'm just trying to share my perspective in this. I think that's one thing that's really bad about this country. We can't even share our own opinions or talk about something.
Yeah, because the Earth is not an opinion. No, because this is not an opinion question. This is a measurement question. We have that one documented instance. I'll give you a list of a whole bunch of other ones. I mean, this isn't an opinion. So you asked me what convinced me. I studied it on my own. In fact, I went out of my way once I was doing a research paper and realized there was something to this issue. I went out of my way to not speak to anyone else about it, to read a bunch of books, to do the measurements and observations, calculations myself, until I came to a decision one way or the other. So because it's not an opinion, so I don't want to hear anybody else's opinion. I want to use my brain to figure out what reality is. So do you see at 33 minutes after the hour?
You talk over me so much that I can't even give my thoughts on.
If you want to talk, okay, this is speculative. Okay. Okay, yeah, tell us. Oh, please, I want to hear that. Yeah, that you asked me why I knew it was flat. So now tell us why you believe it's round. I can't wait to hear it. But also, by the way, right. Before you do that, hold on. I promise I'll give you time. In the chat there, I put a list of observations so you can look at those, and maybe there's one near you that you can empirically test at some point in the future. But go ahead and tell us why you believe you live on a ball.
Okay, so, and this is bringing up something I haven't mentioned before, but I read a book about Archimedes, and so this is that was like 3,000 to 2,500 years ago. Whenever Archimedes was alive, he realized, because everyone back then, every single person thought the Earth was flat because that was all that they could see. But what he realized was that if you in Egypt, so Cairo, I believe, is the capital of Egypt, and the pyramids, he realized that they're on the same line of longitude or whatever it is, latitude. That's what it's latitude. And he realized that at the exact same time of the day, the shadows of the pyramids were of a different length than buildings in Cairo. Now, obviously, these buildings are of different heights, so the shadows are going to be in different lengths. But as the sun moved, he saw that the shadows moved in the exact same way. And the ratios became completely different to where it showed that the Earth had to be at a certain curve to where the shadows would be changing in length. I think that's facts. That's yeah.
Yeah, but you still have not given us this curve measurement then yet.
Oh, I don't need to give you. Well, I don't have any measurements. I'm sure if a Google search, I could pull something up from Archimedes or anyone who says, well, this is. I'm not going to just say, oh, look at a picture from NASA. I don't trust NASA.
No,
but that is supposedly a sphere. So
you said the shadows is proven that Earth have a curvature, so therefore you should be able to show us a curve measurement then.
Oh no, I don't need to do that. If you guys are curious about that, you can look up your shells. But this is one example, and I probably agree with you.
You're making a claim of Earth curve, sir. You're making a claim of Earth curve. You need to be able to demonstrate that. Shadows wouldn't be doing that.
Man, I don't got time for that. I'm just trying to have a conversation without like putting so much effort into it that I have to send you guys the.
Yeah, we get it. You don't care enough about the truth to find out. So, but you want to make a claim without backing it up with citation. We want to see your diagram and your citation. You saying you don't want to go with the pictures of space from NASA because you think we're going to tear you apart 27 ways from Sunday, which we would. But we're still going to also tear you apart. Oh, not NASA, but this dude back then with these shadows that would work perfectly well, no matter what the shape of the Earth was. I mean, if that's all you got and you can't even back it up with any kind of source, citation, or diagrams, then how do you expect us to take you serious?
He had no telescopes at that time, and yet he was able to figure that out. And back then, every single person thought that.
How did he figure out latitude? How did he figure out latitude?
Because of the way the stars aligned or something like that. I don't remember that detail, but I believe it was something about the stars. Like back then, it was crazy how they could figure stuff out like that. Like just using looking at the skies.
How did he figure out latitude again? With the stars in the skies, right?
Yeah.
What was he doing with the stars in the skies?
Well, he was an astronomer, so he studied them, and he figured they were able to figure incredible things.
You do know what latitude is and how they actually prescribe latitude.
I believe latitude.
Can I interrupt for a second? Can you post that? I was listening on the live stream. I've never heard of this one. Can you post that Egyptian pyramid shadow fucking citation in the chat?
He said he don't have to. We got to Google it.
No, that was like the evidence of curvature. What he did cite though was the shadows in Cairo, and I really want to know how they did that, especially when Cairo didn't even fucking exist.
Yeah, on the same latitude. I was trying to get to that.
Yeah, I mean, dude, I could have.
Who did it? You know who did it?
I know the dude. It was Archimedes, I believe. It was one of those ancient. It was one of those philosophers.
You're making shit up, dude. Okay, please stop.
Okay, all right. You know what?
It wasn't Archimedes, and they didn't use the pyramids. You're butchering your bullshit, dude.
Are you saying that you looked this up? Because I'm admitting that I could have my details completely wrong, but I do know what he's saying is the shadows.
Don't you think you need to have your details completely right before you present the claim?
I wasn't. I'm just entering here to have a conversation about this because I personally never really discussed with people who believe the Earth is. Right, I'm not trying to get into a full-blown argument.
I'm just trying to bring up something. Nobody ever told you what you said about measuring the shadows of the pyramids to prove the shape of the Earth. No one ever, 10 years, I've never heard anybody claim that. Not even once.
I guess I like ancient history, so I study a lot of that. I mean,
so post a citation or something, dude.
Yeah, that's if you study it, then you need to study harder, V6. You need to study harder because you got it wrong. He just told you that.
Well, I'm not. Well, can you tell me how I got it wrong, or why you think I got it wrong?
Because that story's made up. The story you told is made up out of your head.
Right. So again, I did not realize I was going to come in and immediately be demanded from you guys that I have to provide citations.
Did you just make that? Yeah, did you just make that up?
I did not. And I can back. It would take me some what's it called? Time and research to find this, but I'm completely fine with giving it to you guys.
How about that? Tell us where you learned about it.
It was actually like it was in a book or somewhere at school. Well, no, I don't go to school. I'm homeschooled, so that's what it would have been.
I'm kind of looking for it myself now.
Okay, so let's find this. Okay, so Thales the Miletus measured the height of the pyramids by measuring the shadow, but that had nothing to do with the shape of the earth. So at the time Thales was alive, there was another guy called Eratosthenes, and he supposedly measured the length of sticks. Well, this is the controversial part, whether it was a well or whether it was sticks, two sticks or a stick in a well or something. That's where the story gets all blurry because there's no primary sources. In fact, there's not even secondary sources. There's just a person talking about another person that said that other person did something. But that is Eratosthenes, and he lived in the same city at the same time, but it had nothing to do with the pyramids.
Okay, so then maybe that's what it was. I thought it was the pyramids, but that is like it was like shadows or something. So I maybe you could be just pulling my leg and making something up to make me admit that that's what it was. I'm not sure.
So, you heard of Thales theorem?
No.
You've never been to third grade? Oh yeah, you already said you're homeschooled. Fuck, dude. Okay, so
yeah, don't you dare make a homeschool joke. Homeschooling is perfectly legitimate.
Well, that doesn't mean they taught Thales theorem in homeschool, but it's usually a standard curriculum in public school. I mean,
if you hang around here, V6, you might learn something. Hang around here.
Explain your theorem.
Thales theorem is like the proportions of a triangle, right? Rise over run.
Yeah, oh, I know, like Pythagorean stuff. Yeah.
No, rise over run, right? So if you know the distance, right? If you know that,
like hypotenuse.
If you measure from the bottom of the pyramid, right, where the shadow ends. Well, if you measure from the bottom of the pyramid to where the shadow ends, now you have the base, right? And from the base, you can get
so it's like
hypotenuse, right?
Whatever. Hypotenuse.
Now you got the height of the pyramid, right?
Mm-hmm. Yeah.
Using Thales theorem. So I mean, that's what Thales did, and Eratosthenes was a different guy that lived a different Greek that lived in the same city at the same time. And he came up, but we have records for Thales. We don't really have records for Eratosthenes. And there's doubt even in the historical record whether this guy ever lived. Because he uses, like I said, there's no primary sources, there's no secondary sources. You have, it's Pliny the Elder writing about Cleomedes, he's writing about Eratosthenes, right? Saying Eratosthenes did this, and then so Pliny is saying Cleomedes said Eratosthenes did this, right? So it's two hearsays removed from the source. And that they use words which don't appear in ancient Greek, and there's problems. I'm not getting the historical thing. The thing is, even that experiment that links the shadows, that works on a flat Earth anyway. It can't possibly prove a globe.
Do you understand? You've been told. Oh no, I thought you were done. No, I was just asking V6 if he understands. Like, you've been told these stories. We get it. Like, you've been told there's ways to prove this globe. That's the whole reason all of us have come here. So I'm sorry if I got impatient with you earlier. I appreciate you being
a moment's thought.
Okay, yeah. So
I just saw it flat. Right. I joined today. I see flat earthers, and I go, "Huh."
Yeah, we're glad you're here.
I know some people think that, so I tried to get, and I was immediately told that I had to provide evidence for just me thinking.
Yeah, just to let you know how it goes around here, like, you can't just like randomly claim stuff and say that proves a globe, because that is a very serious claim, because it's an extraordinary claim that goes against all evidence. Like, V6, you arrived on this earth and you experience as flat and stationary. So if you're going to start telling people they live on this fantasy water ball hurtling through space, you need to have some hard evidence. But yeah, I mean, if you just ask questions like you've been doing and listen to the answers, then it should go better.
Can I? So you mentioned
is there any self-evidence of the globe?
Your experience of Chicago, right? So, given what you said, then basically, if you go there at a different time of day, you should be able to see more of the towers. If you go there at a different time of the day, you should see less of the towers. Like, the height should be changing rapidly based on what you're saying.
That's not the point of the observation. The point of the observation is you should never see it. You understand? If you lived on a globe, you would never see more than the very tips of the highest buildings. So the fact that you can ever see anything shows there's something wrong with the model, but we don't have to rely on...
Like the United States is like 2,000 miles across. So that's just the United States. So the globe, I don't even know how the circumference of the globe at the equator, but that's a massive distance. That's a lot of curvature over a long amount of
I'll show you a diagram
all the way around.
I'll show you a diagram. Can you get back into the into the chat there?
I've never, Chad.
Oh, good. You should look at that. I mean, if you don't have time to look at everything, you can always go back and look later. But yeah, you would think so. So I'm only talking about the one observation of the Chicago skyline. But yeah, it's not just kind of like a thing we just philosophize about or like guess about, because yeah, you'll hear that propaganda lie, that the Earth is too big to see the curve, but that's not actually the case because these buildings that are taller, and it's not just that building, it's, lighthouses, different objects, oil rigs. We can show you the Black Swan argument, which it has to do with oil rigs that are out in the ocean.
Okay, so I'm looking at the chart right now.
And tell me what you think.
It says if you're like, let's pick one, 40 miles away, then the drop in feet should be 1,000 feet away. So
1,600. What? Oh, you got at 40? Yeah, 1,066.
It should be 1,000 feet away. But that's I've seen 40 miles before, and that's obviously not 1,000 foot drop because the land is flat there. So
yeah, that's the point. Yeah, that's flat Earth proof right there.
Yeah,
but the Earth is not. How do I word this?
Flat?
So I live in the Central Valley of California, and you have it surrounded on these coastal mountains. Then you have these massive mountains, the Sierra Nevada, where Yosemite and whatnot is, and it's this valley floor, and the floor is flat. Now I can stand in the middle of the valley, and I can see all the way around myself in the valley. But and you guys would say, well, the valley is like almost 100 miles wide. So you guys would say,
I'm sorry, Mary. Is he explaining your point to you, or is he agreeing with you at this point?
Yeah, I mean, this is the geometry. This is the geometry of the globe, and you're saying yes, at 40 miles there should be 1,000 foot drop, and there's not. That's exactly what we're telling you.
Yeah, because it's not like that. The drops happen.
Then you're arguing.
You need to be yelling at the globe people. Then.
Yeah, exactly.
You need to be arguing with them because their math is wrong then.
Well, I don't know.
This is the globe math. This is the given radius, agreed upon by the so-called mainstream pseudoscientists. They say it's 3,959 mile radius, and that's what the diagram I showed you is based on.
Yeah, you got some questions to ask them, not us.
Oh no, I'm not asking those questions. I'm just trying to see how, if this really is the math, you got 1,000 feet, because I know what 40 miles looks like, and I know it's not. Yeah, there's no drop there.
So you've already So he's observed the flat Earth. Very good, V6. Great to hear.
Then you need to be asking them. You need to be asking them why their math is off.
This is your math though that you're trying.
The drop should be bigger.
This is the math that you've made.
No.
The globe's math is what they're claiming.
Well, this is the math that from people who agree with you that you guys have made.
No, it's obviously math that they put to us. It's the mainstream math. It's what they're claiming their circumference is. I mean, you need to be talking to them about their radius.
Yeah, but
you guys don't need to be complaining to us.
Flat Earth. Yeah. That's a flat Earth. Those are flat Earth people.
Okay, wait. Look up Earth curve calculator, right?
She showed you the globe and what the globe should be doing.
Mm-hmm.
You're saying that's not true. It's actually flat. You need a little bit more.
I'm saying that from my personal experience, the globe doesn't do that.
Right.
But I also can't.
You're not on a globe, bro. You're not.
Right. I also can't see the city of Fresno from where I'm standing because it's the curvature of the Earth.
So you're saying it's flat?
No, I'm not, man. I'm saying if I'm sitting where I'm standing,
this
I
isn't
cannot
flat
see
Earth math, brother. This isn't our math.
Yeah, it's your math. That's correct.
No. This is your math.
That's the great thing about math. It's not based. No, that's the thing about math. It doesn't matter who says it. Doesn't matter what my opinion is, what club I'm in, whether I support the fucking Nazis. The math is the math. You can just do it and check it.
Yeah, that's it.
Or
you're saying
if you can't do it, yeah, you can type into Google Earth curve calculator, and it will give you the same numbers that are in this. Do we own Google? Is Google flat Earth?
It's not math.
Bias don't change math. That's why we use it. Your bias is irrelevant.
It's not something we came up with. She didn't come up with that math. It's what you guys claim.
Oh my god!
Now you're in a position where
what are you guys talking about? All right, I just found this article. I'm going to copy the link, and I'm going to send it to you guys.
All right.
It says that let me pull it up again. It says that the height should be, okay, here we go. It says that the height should be about 0.667 feet for every mile.
Mm-hmm.
Yes. So you should that's about 1 foot. Well, no, that's half a foot for every mile. So at 40 miles.
No, that couldn't be correct. That would be a slope.
Yeah, that would be a straight line. That would not be exponential growth of a curve.
Yeah, remember,
the curve is the same. The curve is the same all the way around. It's not exponential.
It is exponential.
Yes, it is.
No, it's not. It's a curve. It's a curve. It's the same all the way around.
No, it's not. It's not the same level.
It's about 8 inches
looking down your
every
driveway.
mile.
So where did he get that?
Lats is trying to say something. Can you hear Lats?
Who should I tag?
Oh, no,
Lats.
I was just going to say that would be like looking down your driveway. It's just a straight slope downwards.
Yeah, another way.
Unless you're saying you're like a disco ball earther.
Another way to put it, if the guy wants to argue it's not exponential, it's certainly non-linear. Exponential would insinuate some sort of parabola and shit. But the point here is,
Hey,
it's non-linear.
The female is. I tagged you. The link.
All right. So if do you follow how if you stand at one point, you look out 1 mile, for example, it'll drop a certain amount, but then
about 8 inches.
And then the second mile from what you were just describing, it would drop down 16. But that's not
16
the case.
inches.
You're right, but that's the problem. That's a slope, dude. Do you remember your AX plus B? Y equals AX plus B? Or AX minus
the slope of a line?
Exactly. That's what you're describing there. But when you're on like a function that's non-linear, the point at
okay. So can I explain what I think you're trying to tell me? You're saying that basically it's not just going to slope down. It's going to get more. So,
right. The rate.
I can see why you would think that would be exponential. So
that's why I use the more appropriate term is non-linear. But you can actually approximate this with exponentiation. We call it the.
Yes. No, I see what non-linear would apply there.
Yeah, but you can use a parabolic approximation, and we have one, or somebody has one somewhere. And it's useful.
But all that math is in her diagram that she gave you. You just gave her pretty much the same diagram. It still had the radius value of 3959. Still had you the 8 inches per mile square of curvature drop. I don't know. What is you saying that is? Why are you saying
8 inches per mile though is so mild?
Yeah, no. Your source says 8 inches per mile. That is just wrong. Whoever those people are, literacy. Yeah.
I mean, you're the one. You said that the radius value is R.
In Google search, I sent you the measurements, and now you're telling me that those measurements are wrong. So this is why you guys doctored the math.
Wait a minute. You told us it was wrong earlier.
Hold on, bro.
You said it was
exactly because you guys doctored the math. You guys doctored the math to make it look like it's super extreme. And like every 60 feet, you should be dropping like 1,000.
Stop yapping. You didn't send us measurements of anything, okay? Their calculations they're not measured. What did they measure it with?
Okay.
What was the device?
The problem with any
what was the device?
I mean, I believe 9/11 was an inside job. I believe COVID was fake.
You're
I
just
believe
coping right now. You're trying to get your little stupid social
but
narrative
this is one that's
I'm not going to let you. I'm going to just talk over you. I'm not letting you do it, dude. I'm letting you. You've been
talking over me the entire time.
Okay? You're trying to deflect.
Look,
8 inches per mile is a slope. This is not debatable. 8 inches per mile.
We've been debating this the whole time.
Is 8 inches per mile a slope or a curve?
So it would be extrapolated over a curve. But if you were to draw a straight line from that, if you were to draw a straight line
1 mile
from a mile distance of the curve,
another mile it drops another 8 inches. Another mile it drops another 8 inches. Another mile it drops another 8 inches. That's a fucking slope.
Yeah, they made a mistake. If you look at I'll show you exactly where they made the mistake if you want to look at the source. It's down where they first had the squared in the formula, then they substituted a 1, and then they just used that. It's it's a little ways down there where they say h equals d squared over 2r. Then they substitute in 1 squared. Then they get this number, and then they say that that's going to now be their amount of drop per mile, which is ridiculous. They had squared in the original formula. Then when they squared 1, they just decided they just don't understand math. I don't know what else to tell you. That's just the way it is. I mean, this is not a serious source, enviroliteracy.org. Yeah, it doesn't surprise me at all they don't know how to do math. So, we're telling you, Earth curvature calculators, any kind of globe proponents are going to be, accepting the formulas that we're giving you. You can sit here and argue about math if you want all day long, but I'm just telling you they're wrong.
My math was wrong, though. You guys are telling me that the math I did was wrong.
To you. No, not the math you did. What you searched up is a bad source. That's a bad source. They made a mathematical error in that.
And you guys said it was wrong.
My God.
You guys said it was wrong.
So V6, why don't you hang out till Matthew Lawrence comes in here? He's a math professor he's a globe earther. He's a math professor at Loyola University, and he can come in and tell you you're fucking wrong. Okay, you're wrong, bro.
Okay. What am I?
I don't even know why you're defending it. It's obvious. No, the 8 inches from out squared is a slope.
No, I admitted that I was wrong when I made the uninformed statement that the curve was not exponential. I can now see someone. I don't know the kid's name, but he helped me see how it is.
Yeah, remember that was the first thing that you was arguing about. Now you were saying that we was making up the radius. You said that we was making up that radius value of 3959. That was the thing that you was arguing about.
Oh yeah, no, they're not that. I'm saying that the thing that I sent you guys about how it's just 8 inches, but then that 8 inches adds up, and it's over time, it exponentially grows. It's not just like a slope, a straight line, because it's a curve.
I'm glad you've conceded that. He's conceded that. Thank you. Do you have another question?
Yes.
Obviously, we argued it because we're just a bunch of conspiracy theorists. That was silly, dude. To even fucking insinuate that shit.
What?
Yeah, somehow we're just saying you're wrong because we're just conspiracy theorists, and that 8 inches from out is not a fucking slope. I mean, dude, like for real. That shows you're not being honest. You.
No, that 8 inches per mile, that would be what you guys would call a slope. However, if the curve really was true, which I believe it is, that 8 inches per mile is over a mile, you drop 8 inches, and then another mile, you drop 8 inches.
That would be a slope.
That's a fucking slope, dude. I just described it to you. It's non-linear. You can use the parabolic approximation, right? You're forgetting to introduce the square in that, right? Pick a picture. If you have a little Lego man, right? He's standing on top of a basketball.
Mm-hmm.
Follow? Take a ruler and put it right under his feet so it extends out.
That was kind of what I was trying to make the point. I wasn't explaining it well, but yeah, continue.
Right? So after 1 inch on that ruler, if you do a drop measurement, like completely vertically, it's going to be whatever, a centimeter or whatever the fuck, right? If you go another inch or another centimeter, or whatever,
I understand.
Is it going to be 2 centimeters, or is it going to be more than 2 centimeters? Starting from the same point where his feet are.
Well, it's going to be a little bit more than 2 centimeters.
Right. So not 2 centimeters. Right. So it's not 2x.
It's going to be a little bit more. It's going to be 2 times whatever that. It's going to be times that curvature coefficient, whatever that is. Right.
Right. Yeah. So what we're describing here, the 8 inches per mile squared, 8 is some scalar, whatever. Somehow it was derived backwards from the other math involved. Per mile, 8 inches per mile squared. So you square the mile. So after 2 miles, right, you square that. So you get 4. Multiply that by 8 times 4 is 32.
I don't know if it's squared though. I'm not sure if it's 8 inches to the 8 inches power.
Bro, if you use the parabolic approximation, this is what you get.
So you're saying that every time you go 1 mile, you square that 8 inches?
Walk through it with me. Okay, you're standing on the shoreline somewhere. You look out perfectly horizontal. Okay, imagine your feet are right on the ground. Your eyeballs are right on the ground, right?
So then why would a ship just disappear as it goes farther? It goes down and down until you can only see the top of the ship, and then you can only see part of the ship.
You're moving on.
And then you can't even see any ship.
Do you want to walk through it with me so you can visualize what's going on?
Well,
so you can better understand?
Visualize how you said it. It is exponential, how it goes more, and a little bit more as it keeps going. But I'm not sure if it's squaring itself every time. I'm not sure if it's that.
I'm telling you, using the parabolic approximation, okay? A good visual for it is if you take a basketball, or let's say a baseball, it's small.
Yeah, I know. I understand the visual approximation.
Let me finish. And you cup your hand over the baseball. Your hand is what's representative of the parabola. Right? Your fingers would not.
Yes.
Fingers don't wrap around.
Half a parabola. Yes.
Exactly. If you extend your fingers out straightwards, it's going to create like a V or a U shape around the basketball. And the tips of the U's will touch the table, and the ball will still. You see what I mean? So in the I just mean your fingers. Let's say instead of your fingers curling completely around the ball, they would just keep going off. just picture like a cup. Picture a cup around a ball. Okay, it's a better way of looking at it. You see?
Yeah, I don't know why he's
Yeah. Anyways, the point here is take it to the Earth scenario that we're talking about. The 8-inch per mile squared approximation. Picture it, right? You're on the shore. Your eyeballs are right on the shoreline, right? You look straight out. 1 mile out, the drop is supposed to be 8 inches. After 2 miles, right? You have 8 times 2 squared. So you square the 2. It's 4 times 8 is 32. Right? You see the greater jump from 0 to 8 and then 8 to 32. You see that? Take number 3, for example. 3 squared is 9. 9 times 8, 72.
You're saying, okay, so hang on, I tapped out for a minute, but you're saying that 3 times 3 squared is 9. But what is that 3? Where do you get, what are you saying 3 what?
This is the 3rd mile outwards, right? So we started with
so
0.
the 3rd mile outwards, so you have 9 miles.
Yeah, correct me if I miscalculate here, but you see the greater and greater increase, right? From 0 to 8, that's a delta of 8. X is 2, that's 32. The delta from 8 to 32 is 24. So we have a delta of 8, then a delta of 24. Then at mile 3,
72.
right?
The delta, which is change, right?
And the delta between X2 and X3 jumped from 24, right, to 30 to 72 minus 32. That's 40. The deltas are gradually increasing. It's nonlinear, bro. And we use the parabolic approximation.
It gets you 128.
There you go. It works perfectly.
4 miles.
I think the math works out to be accurate within 3 or 4, maybe even 5 significant figures, up to 1,000 miles or whatever. It's kosher. After that, then it starts a little bit deviating. But for our purposes, it's perfectly fine. You follow now?
Faintly.
Anyway.
Yeah, I don't know. You guys are definitely different than other conspiracy theories because I believe almost every conspiracy out there, but I was immediately confronted and told that I was believing some fairy tale or whatever. I don't know. I don't think that's how you win people over.
Why do you keep bringing up conspiracy theory? When did we bring up a conspiracy?
Yeah, I don't know why.
When you say that the Earth is flat,
How is that a conspiracy?
that's viewed as a conspiracy theory.
I don't care what people view it as. Are we saying it is? You're
Yes.
straw manning like our
I'm
position.
saying it is.
Oh, we did? When did we say that?
I believe it was
Why would
mentioned
you
that
think
it was
flat Earth
as
is
a conspiracy.
Well, why would you think
Well, okay, so I believe that. I believe that George Bush and Larry Silverstein planned 9/11, but I still call it a conspiracy theory. Is what I'm saying.
Okay, the official 9/11 story is a conspiracy theory. The official story. Because
I wouldn't confirm that. I wouldn't call that as a. I know the point you're trying to make. I understand the point you're trying to make. However, I don't refer to it.
Conspiracy.
I don't refer to that as the conspiracy theory, but I see the point that you're trying to make.
So when Robert Mueller testified before Congress and said they never found anything about the plot either in Afghanistan or the United States, it's not a conspiracy theory? They have a conspiracy. They have a theory of what happened, but they have no physical evidence. Meaning they have no physical evidence that Al-Qaeda planned it. The 19 hijackers have zero physical evidence.
Yeah, exactly. And the fact that these pilots who had flown, technically, like I said, I see the point that you're making. However, I don't refer to it as a conspiracy theory because then most people would call me crazy, right?
No one here. I've been here since you got in here. No one here has mentioned conspiracy theory about flat Earth except for you.
Look, everyone thinks 9/11 is a conspiracy theory because you have to believe one person did it all. You have to believe the lone wolf theory of 9/11, whatever that is.
No, it was Larry Silverstein who leased the building, who got
the point is the closet. Everybody thinks it's a conspiracy theory. That's the difference. It's only an argument about who was in on the conspiracy.
Because it's multiple people. That's what makes it a conspiracy. I see. Okay.
Yes. If one or more people planning to do something, it's a conspiracy.
Essentially, yes.
So when Congress gets together and says, "Hey, we're going to pass a law," that's a conspiracy.
Yeah, so the difference between those other topics that you said you've researched and the flat Earth is that you can go out and test this for yourself. You don't have to rely on, investigating and figuring out mysteries.
I've stood on the shore of an ocean and I've seen a boat go out, slowly get lower and lower. All of a sudden you can only see the sail, and you can only see the top half of the sail. All of a sudden you can't see
that. You just read about it.
For 5 years. I saw it every
know
day.
when someone's making shit up, dude. I live by the ocean.
Prove me wrong. Go to the
what ocean was it? Okay, I'm going to ask you for specifics now. What ocean was it?
It was the Pacific Ocean.
Where in the Pacific?
It was the Olympic National Coast.
He lied,
National Park Coast.
Okay, stop it.
The Olympic National Park Coast. I know exactly where that is.
Exactly.
Actually, we have the bird sanctuary there. We got the bird sanctuary.
No, I was at Gillette or the Rose Beach. It was Ruby Beach, I believe it was called. There were a lot of beaches there, but
yeah,
I've been to several.
I remember which one you saw ships go over the horizon. I know, it's super hard. It's full of shit, dude. Like we've done this a lot of times. We've dealt with thousands of people. Like your little accident.
Okay, so but it doesn't matter which beach you're at.
I remember
the water's the same.
Bro, I remember you from the other server. That's why I'm giving you a fucking attitude. I remember your bullshit from the other server.
Like what server, dude? Honestly,
24/7 flatter Discord.
No, I've never. I came in and I heard it. I've never.
That put my fucking antennas up. Yeah.
Dude, there's another person like me, bro. It's literally. I came in here and I came in here and I said I never heard you. I never really heard a convincing flat Earth theory.
Yeah, dude, you're saying all the stupid shit that you said before too.
No, but it's because I was trying to use.
You're the wrong person, man. Like you really are.
You're really paranoid. You're really paranoid.
You said that. No, I'm not paranoid.
The people who were in here when I came in.
Everything.
I literally told you that.
30,000 hours of fucking recordings.
This was like 45 minutes ago. It's like 45 minutes ago. When I came in, I said I never heard a convincing theory.
2 years ago. You were there. I remember. You were doing the same thing. You were doing the exact same thing. You interrupted 9/11. Yeah, it is hilarious. You thought you were just fucking going to the radar. That is hilarious. Yeah, it's funny.
I didn't even have a phone.
Keep trying to post some bullshit.
With the 6'd, you have eyes. You have eyes. Look at the side shot. You are talking about the ship zipping. Look at it. It's zipping and appearing. And you don't have eyes.
Oh, yeah, because
you don't have eyes, right?
It's obviously a very.
That's my next. Why the ship is zipping and appearing? You have eyes.
Dude, you can see how the atmosphere is terrible.
He heard all this before. He heard this.
If I was a pilot and I was trying to like stay in the sky and I had to like fly at a certain altitude from the surface of the Earth all the time, then I would technically have to like fly above the atmosphere at this like localized sea level idea that like the Earth has like a constant rate of altitude relative to the surface. I would fly into the side of the mountain unless I had to like go up the mountain, you know.
Well, they got a lot of equipment that they use, but I mean the planes themselves are designed to, all the calculations in the aircraft design treat the Earth as a flat stationary plane. It's in all of the.
Otherwise we'd fly into the side of a mountain. Really, this is the problem. Yeah.
So is the curvature space-time related? This is an idea that globies haven't really come up with, and is not part of the current modern cosmological paradigm. Some globies have come in and suggested as such. Smart ones, I think. Moving the goalpost even further. Because if it is, it means you have no hope of detecting curvature at all, because you are in the frame of reference that is being curved, where the Lorentz contraction is happening with regards to Earth's motion and gravitational alignment with the mass. It means you have no hope of actually knowing, and this would comport to Einstein's idea, right? That you couldn't tell, you can't have any absolute reference frames. Basically, in Einstein's cosmology, everything could be at rest. Everything at rest. Absolutely at rest. And the only thing that's moving are 11 dimensions of space-time, giving the appearance of movement when there isn't. And curvature and other geometric shapes.
We're free-falling. Is that what you mean? We're not moving?
Not even that. Not even that.
That's his understanding. That was Einstein's understanding.
Well, his own framework allows for you to be stationary, and you're not falling, but everything is moving away from you, right? Isn't that what the Big Bang explosion is?
Well, yeah, moving up. You remember he was walking along. He was thinking about the guy falling off the roof.
Oh no, it's the elevator, right? Where you're like in the elevator.
Or the elevator.
You get snapped and you don't realize you're falling because you're falling in frame of reference.
But his point was you could think about it as the guy falling off the roof. He's motionless. He's not going anywhere. It's that everything else is moving up towards him.
Yeah, space-time itself is warped up, and we can't detect it because we are within the frame that's being warped, and it looks like it's not happening. The guy looks like he is falling instead.
That's what bollocks to me.
It is bollocks. Absolute. But this is what Einstein came up with. It's the ultimate unfalsifiable claim for cosmology that cannot be proven to exist, that everybody can latch onto and explain things with. Sorry.
And every moment in time that you experience being in motion, right? Everything's just going to appear as if it's just flat and motionless around you.
Yeah.
Unless it's moving faster than you.
No, then it's stationary, and the space-time is moving faster between you.
Well, the idea of the falling is that we have a terminal velocity on Earth, right? So in our frame. We're talking about objects. We're not talking about light. Like when we actually do like the speed of light equations, then we're talking about stuff that moves faster than the speed of light, and that can't be proved yet. But when we're talking about like the man falling, and he has a he has a point of reference, right? Which is
that's all frame dependent, though.
Vision, yeah. But if something moves faster than the terminal velocity, then the frame of reference will, have that reference speed in it as well, right? So it's easy for us to imagine as humans what the terminal velocity is because we all fall at the same speed. That's why we're all in free fall together. That's the idea.
But do we?
Yeah. But if something moves faster than us, then we have to like take that into reference. But like speed of light is the cap, right? And that's how we get the terminal velocity because we're measuring the speed of distance over time, based on the object's mass, based on gravity, right?
That's within our frame.
Yeah, and in the Earth's frame.
Arbitrary. In Einstein's cosmology, that's also arbitrary. It is a valid explanation but it's also just one of an infinite number of interpretations that can be true. That's the problem.
But it is still true.
Well, yes, it is one way to interpret it that is valid, but it's not ultimately true. What is ultimately true in his framework is that all interpretations are equally valid, which would include a flat Earth. I'm starting to get it.
When I brought up black holes yesterday, I kind of just got like laughed at.
You will.
Yeah, but event horizons, like when we're talking about like horizons and vanishing points, and we're talking about light and gravity and like the fundamental forces of the universe, we're not talking about human perception anymore, right?
Which is not a force.
We're talking about like the capabilities of the forces in the universe. We're not talking about what we perceive them to be.
Within the mathematical equations.
Right, yeah, these are all conceptions. One valid interpretation.
Yeah, so like when a black hole was theorized, it was like we didn't have an observation for it. And then it was found, and it was like, wow, guys, we found a black hole in space.
Are you ready?
Really?
That's what happened. Yeah.
Really?
That's what happened. Yeah, that's what happened. It was like this is a theory of like how gravity works, and then they're like, hold up a second.
It's something you can validate.
Listen.
Yeah. Go ahead.
You don't think that's how we have like smartphones today?
No.
You can't draw the correlation there. Like, can't see it.
Cell phones.
Mathematics is fun, isn't it?
Like the way that we all have like access to cellular device. Like
cell phones are radio devices. There's nothing spooky wooky about it.
Yeah, why is it whenever we send signals, all of a sudden we're on a ball?
Wait, but don't we have GPS systems on our phones?
Yeah,
sorry,
yeah, those are radios too.
I mean, you can put a GPS system on anything, like an AirTag on a car, on practically anything these days.
Yeah,
and it's accurate.
And so we're going to be using an awful lot of triangles to triangulate our position.
Well, no, it's accurate because we understand what gravity and light is.
Well, no,
are you forgetting our conversation an hour ago?
No, well,
light technical on this.
Because we just mentioned about. Oh wait, I think like we're regressing. Yeah, you're true.
Yeah, I already described how they transform azimuthal and elevation angles from the GPS network into Keplerian orbital elements.
Yeah, I was just talking about black holes and like the light.
Yeah. And you brought up GPS.
Then you went here. You started talking about mobile phones and my toaster works.
Yeah, but that's because our understanding of how light works
is just one interpretation according to Einstein, and is not the ultimate truth. This is within your cosmology that I don't even agree with.
But we agree that our understanding of light got us to here, where we are today.
We understand that's the claim.
What is light? Our understanding of light. Okay, what is it? What do you think it is?
Well, it's a wave and a particle. It's confusing. Okay.
Yeah.
It's a wave and a particle. That's a wave.
We don't have a unifying theory between quantum mechanics and cosmology.
Yeah. Yep. It's a wave function, isn't it? That's mathematics.
That's physics.
No, that's mathematics. The wave function. That's math, isn't it?
Yeah,
it's actually waving.
It's a measurement. Technically,
it's a statistical probability of where the light will be in the future. That's the wave. It's a probability function.
You don't need to. You put the numbers in afterwards.
The wave is a probability function. It doesn't really exist.
Yeah, if you put the numbers in first, you're brute forcing it. That's the wrong way to do it. But you can do it that way.
The wave is a statistical probability function, dude. That's all it is.
This is probably one of those times where I actually do wish quantum arrays also.
Yeah.
We start talking about quantum mechanics and then we start talking about.
No, I just mentioned it.
What light is. I know I get your point, dude. It's just we wouldn't have these things without fundamental understandings, but the understandings our gentleman has a slightly skew.
I mean, my whole point to you this time, Luke, is what you're claiming to be absolutely true is not a fair statement within the unprevailing cosmological paradigm, where multiple coordinate reference systems, multiple points of origins, can be reinterpreted just as validly as others using relativity, because it's all relative.
Yeah, we were using like our understanding of the Thor experiment of like inertial frames, right, as like how aeroplanes can fly flat, because they have an inertial frame, because nothing moves faster than the speed of light, and that's just what the point was, right?
You can choose to use Earth as at rest state of inertia. Absolutely true. But then you say, but we know it's not. And then we say, well, how do you know? What's the tiebreaker here? Let's get back to the surface and measure the curve.
Like, if information could escape the black hole, which we think we have evidence of, right?
Mm-hmm.
But it's not light in the same wavelength as visible light, which is different, right? So the information's kind of shifted some way. It's interesting stuff. Because how does that affect us on Earth when we're talking about like planes of reference?
This is all, in my opinion, fantasy mathematics.
Yeah, theoretically.
Well, no, we have the sun. That's what powers our solar system. Right, the space, the universe is.
Well, the sun is
our solar system.
What's the sun?
Solar system is one interpretation too, right? You've got the Copernican, the Tychonian.
I did ask you, like, when we look at the same sun in the sky, we're looking at the same sun. Yeah.
What's that then?
What do you mean? What's that then?
You know, the experts don't agree what it is.
Well, it's a point of reference. That's what we're agreeing.
Oh. Is it fixed or moving?
You know what a point is? It's a point of reference.
Is it the point of origin itself moving within a larger framework?
Well, I wouldn't be able to tell you that with a singular point, would I?
I know.
That's the problem, I guess. So if we look at the galaxy, right, which is the next step up, is there any more suns in our galaxy? Any more stars?
What's this?
Okay, try to get back to the surface of the Earth again. You're like,
well, because we're talking about visible light spectrum, right? We're talking about human eyes, like the capacity of like how far we can see. But then when we change the lens focus, right, and we use like telescopes, we can see a lot further. But our eyes can see further, but we just use different lenses, right? So the visible light spectrum is still there.
Seeing further with the telescope, are you?
Yeah, you're seeing the light that's there, right? Because it's there, and the further you look, then you have to measure it in distance. Right now we have light years. That's how long it takes the light to arrive to our eyes.
I don't think that's how telescopes work, bro.
That's right.
No,
you can't get distance from telescopes. Period. You have to have a reference of a known size or distance.
Yeah, we actually don't. You're right. We don't use telescopes to measure distance. We use the size of the object.
Right.
And the color it gives off the temperature.
We know what we're talking about, dude. We're not crazy.
Yeah, I also know what I'm talking about. You sound like
I appreciate your concessions.
How do we get the size?
That's the question.
We look through the telescope and we see the light.
We see the light.
Yeah, that's
how do we know anything when we look at something for the very first time? We've absolutely no other.
Wait, do you know what the visible light spectrum is?
Yeah.
We have an idea.
Do you know what the EMFs is?
Yes.
Yeah.
Right, so the visible light spectrum is on the EMF spectrum, isn't it?
Doesn't mean it is.
So
doesn't mean light is electromagnetic, though.
When we look through the telescope, do you think we're looking with our eyes or we're looking with the sensors? We can do both, right?
Yeah, you can use a sensor.
Why are we doing this pedantic semantics where you're thinking that I don't mean what I say?
I don't know what you're asking.
Size and distance of objects.
Just saying the words as they are presented in the fact. You know?
A lot of times we're asking questions because we know the answer already. And most of the time there won't be an answer that anyone can give. And it's more of a shit test to see if the other person is capable of conceding.
I'm trying to understand if we have the same understanding of light. Okay?
Yeah.
This isn't like I gotcha, haha, you're wrong. This is like, hey, can we all play from the same book, please?
Yeah, I mean, I don't have a problem accepting that that people don't fully understand what light is.
No, I'm not questioning.
I don't have a problem with using a framework that people create to best understand it, such as the wave-particle duality of light and so on. I don't have any problems with that. I have a problem when people spark up with absolute certainty that they know that this is the case, that this is how it operates. We understand it, and there's nothing left about it that we need to know.
Well, that's practically the reality. We don't have a unifying theory between the two. Right. And if we did, we wouldn't be having this conversation because we would have the theory. That's the problem.
We're having this conversation because we can't measure any curvature of the Earth that everybody insists that everybody knows is there and somebody's measured it at some point, but nobody can produce the evidence for it. That's why we're here.
Yeah. And John Wick curved that bullet, right?
Wait, what?
Do you understand how troubling this is for us? I mean, listen, the second and third order effects are being corrected on
I've been trying to talk to you for hours, man, and it just seems like you don't want to engage with the reality. You just want to understand something that's not there.
Okay, let's go back to the surface of the Earth then.
Reality.
This is about this
you guys
point
keep going,
where the conversation went drastically downhill. So, Luke, try to just chill out a bit, dude. Right? We don't want.
Yeah, thanks, DJ. Cheers, man. I've already said my part. Thanks.
Just chill out, dude.
Relax, man. Isn't it nice relaxing right here in this moment? I mean, appreciate what we've discussed so far, where we've come, what's still ahead of us. There are huge problems on the table that should be obvious to everyone, but isn't. If we're right about this, what does that mean for the last 100 years of credibility, of institutional knowledge? I mean, we're playing with fire, folks. No doubt about it. I think it's kind of cool to just chill out right now and appreciate what we're digging into. If we can relax, we can move on and continue the discussion, progress it forward. Willing to do that, Luke? I am. If you want to take a break, it might be a good idea too. We can do that. We're here 24/7. You might get different people. We're not all chill. We try to be.
It's tough because we're attacking, the core fundamentals of it, but people want to skip past that.
Yeah.
And and go into the weeds, off into like, well, just like now we're talking about galaxies and things. Like, whoa, you don't even know what Earth is yet, and you want to assume you know what the universe is made of and all that.
Yeah. We got a long way to go. Let's start with that curvature measurement. Let's start with that, right? We were talking about how you ascertain distance with a telescope. You need to measure something first to have an object of reference. Can we just get that curvature measurement, folks? Because if we can, then the rest of this cosmic distance ladder may be true. But that part has not been done. The foundation of the cosmic distance ladder for our entire modern cosmology depends on this curvature measurement. It's that fucked up, dude. I wish it wasn't the case. It kind of feels like a nightmare at times, to be honest.
Do you know what a Fourier transform is?
Yeah, like in electronics or for sound and music.
Yeah.
Yeah.
Like signal. Yeah, like a frequency.
Yeah.
Like we like
waveform transformations.
Yeah. Yeah. That's it. So like when we get like a signal, right, and it's like in our little like lasers, and it's like not the signal we thought it was, we can just do like a Fourier transform and like work out what that added signal is. Yeah.
Yeah, like for it's great for building filters and signaling, finding signal within noise. You do different analyses. You transform it different ways. You can see what's what in the in the soup of data.
We speak in different ways, right? So we could differentiate between our like vocal patterns with Fourier transforms, right?
Yep.
Cool.
Yep, I understand. I mean, it's been like 30 years since I've had to think about this. 20, 25. Yeah. Things I'm doing in my life career-wise right now are much different than what I began as.
Yeah, there's like a lot of science that goes into like getting a clear measurement. And what I think I'm hearing you saying is that like the curvature calculation is like we're like using all of this correction, and it's not giving us a good enough equation so that we can actually work out the curvature observably. Is that one?
Yeah, nobody has been able to measure the curvature of the Earth ever directly, not even once. Not without invoking transformations in math that are not observed.
And that would be because of all of like the background noise, essentially, right?
Well, I mean, if that's how you're looking at it, like I described with Helmert's Higher Geodesy, written in the 1880s, they kept noticing over time that when they were doing surveying that they could see further than the curvature of the Earth would allow, so they started correcting that by mathematically calculating the Earth to be fatter and have more surface area than it really does.
I wish I took a picture of the sea when I was driving. I could take it. I will. This is a 24/7 space, right? So I'll capture the image for you. But sometimes when you're on a hill going down the hill towards the sea line or the shore, the sea level is going to be higher than your perpendicular 90-degree measurement to the horizon, right? Like the sea's horizon is higher than you are standing on the ground, and it's almost like a mirage or like an optical illusion.
Perspective. It appears higher. Yeah, but if you're looking at the surface of the sea, you're still looking downward at the surface of the sea.
Yes, that's
the
why
angle is so small. Yeah, it could be like arc seconds of tilt.
Yeah.
Yeah.
But your eye level is it's parallel with that sea level, so you're gonna have to look downwards a little bit from your eye level.
Yeah, like I live in Kent, which is Dover, right? And so you can see like over to France. Like if you stand on the White Cliffs of Dover, you can literally see France.
Yeah,
I love that you said that.
See it from the coat from under at the bottom of the cliffs as well.
Yes.
Yes.
How many miles is that?
22.
Yeah, something like that.
You've been there too, Jedi, right?
I live there.
Yeah, that's your observation. It's your flat Earth observation. We all have it.
It's intuitive to think that like the distance is like we shouldn't be able to see it over the hill, but the water doesn't really create the hill. That's like one of the illusions, right? But you're saying that no matter how, like, there's no way that we can measure this hill on the water because it always appears flat.
Yeah,
it is flat. Right. Look, I have a really good 21-mile observation. I've just been snapping some screenshots out of the video. I don't know if you've got time. I could just go over that with you quickly. I mean, it's a really, really well done observation. Luke.
You have time? Do you want to take a break? Luke?
Sorry, I had a signal breakout. I didn't hear anything if you were talking to me.
Yeah, so I got a really good 21-mile observation over the Great Salt Lakes in Utah right now. I've got a quick little presentation like to go.
Oh hell yeah, let's see it.
All right,
okay.
Rock and roll, baby.
Yeah, I was just snapping some screenshots because let me just like present it and then we'll discuss it afterward. Okay, so this is the Great Salt Lake in Utah on a very, very still day late in the afternoon. And here's just a picture of the location. And you can see in this image how still the lake is on this particular day. Okay, so this little peninsula that you can see here is 21 miles away from the shoreline on the other side of the lake there. There's actually a town over on the other side of the lake. You can't see it because it's so far away, but you will see it in the next slides. Okay, so next.
Wait, this doesn't show a hill of water though, does it? I'm not seeing the hill.
No, there is no hill of water, right? This is showing a completely flat surface over 21 miles. Yeah, there would have to be if the Earth was a globe. Right, so this is the location on Google Maps.
Wait, how do we take a flat? What is flat on the sea? Like, is it sea level 0? Is that what we're doing?
Yeah, no drop over distance.
Sea level is.
Yeah, in this context, we're just talking about there's no drop over distance between point A and point B. There's zero slope. Right, so you can have a look at the observation distance check. Right, you'll see that it's 21 miles. That yellow line on Google Maps there has been drawn.
Wait, if I sail north to south, right?
Hold on, let me go over. Right, hold that question. Right, just let me go over this observation quickly. Is that all right?
Oh yeah, sorry, yeah, I was holding.
Yeah, it won't take long. It'll just take a couple of minutes, and then we could just remember that question that you just said about the navigation. Okay, right. So here's the Earth curve calculator. We have a 21-mile distance. And this shows that there should be 223 foot of obstruction from the 5-foot observation height. Okay, so I have a screenshot of the camera setup just here. Yeah, I didn't screenshot that one. Anyway, he's got his camera set up just sitting in the water on a tripod just next to the little bit of land on the shoreline there, and it's 5 foot off the surface. You can check it, like there's a full video that goes along with this. This is just screenshots out of the video, so I will post the video after as well. All right, so late in the afternoon, he does the observation, and this is what it looks like, right? He's got a friend named John on the other side of the lake, where the town is 21 miles away. So this is what it looks like on the shoreline of the other side of the lake. And we can see, as a good reference point, we've got this big white silo tower thing. I'm not sure exactly what it is, right? But that's what it looks like close to that town. Okay, now, Taboo Conspiracy, which is, I think he's like an attorney or something like that. He's the guy that's doing this observation. He's over 21 miles away on the other side of the lake with his kids. Doing his part of the observation, right? So he sets up the camera 5 foot off the surface of the water, and this is his view from the other side of the lake, right? So this is a couple of hours later. They're doing it right on dusk when there's minimal, there's less heat haze and stuff like that in the air late in the afternoon, right? So that's why they're doing it then. And after this, they're going to do a laser test, right? Once it gets dark. But don't worry about the laser test part just for now, right? So we can see that from 21 miles away. We can see basically the same thing as what we can see from 21 miles closer in the image just above it, right? There's nothing obstructed, right? If the Earth was a globe, there should be 223 foot of obstruction. And from 5 foot, you would have to have a horizon, like a physical geometric horizon line at roughly, I think about 2.7 miles or something like that. All right, so here's a slightly closer zoom of the tower. Right, so there's no horizon present whatsoever. We just see a flat surface of water from point A to point B. Right, and now what they do after this observation, which the observation in itself is pretty good, right? After this, they both have high-powered lasers, right? So he shoots his laser across the lake to his friend John, who's on the other side of the lake. And John also has a laser, right? So they're going to point the lasers at each other and see if they can see each other's lasers, right? If the Earth's a globe, the laser beam neither of them should be able to see the other person's laser beam. And yeah, you can have a look in the full video, but you can see, right, this is from 21 miles away. Not only can he see John's laser beam, but he can actually see the beam also reflecting off the surface of the water. So I'll post the full video to that one if you want to check it out at some stage. We got a ton more like that, but this is a good one because it's just such still conditions. So yeah, I'm done with that. Were you following along, Luke, or was I?
Yeah, I was listening.
Okay, cool. Thank you. Appreciate it. Yeah, so there's tons of laser tests like that, right? Long distance observations, laser tests. It's been repeated over and over again, right? And like I was talking about, certain characteristics must be there if you ask a globe of the claimed size, and we're not finding them present.
So, I'm gonna present a little thesis, maybe a little bit, about the difference in elevation and how this could change the approximate distance for the apparent drop off. Because the higher you are, the sea level should be relative to that. So I'm gonna work all this stuff out, and I'm on ChatGPT now. I'm gonna try to do this for you.
Yeah, we've taken that into account already.
Yeah, absolutely. It's such a minuscule difference. But yeah, take it into account. It's valid, right? It does change the radius.
I hear what you're saying.
It changes the radius value slightly, but it only changes it. It changes it from like 3959 to like 3959 point something, or it's just such a small difference. So it really doesn't, because we can see so many magnitudes further, right? We could see like 2,000% further.
Yeah, like the lowest point of the Earth, like we can measure from, and the highest point of the Earth that we can measure an arc minute from, right? These things, the difference in the highest and lowest point is going to be the difference in the inverse. It's going to be the relative difference between the amount you should be able to see the horizon from at that elevation.
Right. That formula is 1.225 times the square root of the observer's height in feet in miles. So
yeah, nice. Thank you for that. Because what your calculation should allow is that there would be like a local maxima for where the drop off starts. The local minima for where the drop off starts, and there should be a local maxima for where the drop off is indefinitely happening, right?
So from 1 foot, that's 1.22 miles, and for 6 feet, it's 3 miles, and so on, in accordance with the formula.
That's right. So at 100 miles, right, based on like the function, 100 miles we should plug in 100 miles, and it should just say out of sight, right?
The 100-mile horizon distance.
Yeah, I
don't know what elevation you need to be to see that. Maybe like 15,000 feet or 20.
Well, I think I'm going to try to create the function for us so that we can like run a little script and just like play with it and work out.
See my spreadsheet? Let me post it. Just a screenshot.
Cool. If you have data for me already, that's really helpful.
Oh yeah.
Yeah, I just asked ChatGPT and it doesn't understand what I'm asking, so I'm
Yeah, mine does, because I've asked this one before, right? So this is what I typed in, right? So I said, so this Great Salt Lake is 4,200 foot above sea level, right? So I wrote into ChatGPT, if the surface of the Earth were 4,200 foot higher everywhere, what would the new radius of the globe Earth become? And it says that the new radius would be, instead of 3,959 miles, it would now become 3,958.8 miles.
Yes, that's supposing that the radius is constant.
Yeah. Hey, look, I posted my equations and a spreadsheet screenshot, so you can see it along with pre-calculated heights to get a sense of scale.
Oh yeah, sorry, I was listening to DJ. Open this and close it because I can't read this.
We have a math professor in the chat right now as well, by the way, so he can always help out these to help us confirm our math is correct. Hello, Matthew.
In this things right, I can't see where's the step distance of the radius. So like we have one radius measurement, which is like where we are, and then like the next radius measurement is where we're going to be.
This isn't right now for expanding the radius, but what it is presenting you is first how much of Earth's surface area is visible if it's a globe with a fixed radius from a certain height. Secondly, where the horizon should be if it's a globe from a certain height. And third, what that dip angle is from a horizontal relative plane of reference.
So you have the horizon distance as static values here, yeah?
The horizon distance is based off of the static value of Earth's radius. This is not showing you like how big the Earth would be if you saw too far. There's if I had access to my workstation, I could just go in and change a few cell references to do it, but I'm stuck with this right now. I'm also cooking.
Yeah, what I need is like the radius from where we are, and then like the radius from where we are going to measure from. So that would be like the camera point is us, and then like the beach would be the second radius. And I need to know the distance, the arc distance between those two radius relative to the height.
It's a super simple way of thinking about it.
Above the surface.
Right, so we've updated, because we have a higher elevation above sea level, 4,200 feet, right, we have a new radius value to work with, which is 0.2 0.2 feet different. Sorry, it's
right. So that's just so you're saying
instead
that
of 3959, let me correct myself. Right, instead of 3959, now it's 3958.8. Okay, so based
Why is
off
it smaller?
Oh, sorry. Let me.
It should be if it's 4,000 feet higher. It should be about 2 miles larger. So 3960.
Yeah. Oh, sorry. I read it wrong. So it's actually 3959.6. My bad. Instead of 3959, it's 3959.6.
Yeah, that sounds right.
Yep. So based off that new radius, right, the horizon is now should be 2.74 miles in distance instead of whatever. Let me double check what it was. According to the Earth Curve calculator, based on sea level, it's all right. So it should have been at 2.38 miles, right? We can now update that to 2.74 miles. So it's just the slightest bit difference. That's why I was saying earlier, it's like it's not something we really need to worry about because it's just negligible, considering the magnitudes further that we can see. Right, there is actually no horizon whatsoever present in the observation. Right, so there's no horizon at 2.74 miles, right, or at 10 miles or at 20 miles. It's just there isn't one.
Yeah. That's But because we would, even though like for me it looks like we're just looking up a slope still. What I was going to ask earlier about
up a slope, right? You just have linear perspective to take into consideration. That's all.
Right, because what's happening biologically is the light is entering the aperture of your eye, right, the iris. And as it does that, it diffracts a little bit around the edges, and then it hits your lens. Your lens is like a football shape, right? You've got the center of the lens, which forms your optical axis. And the light then crisscrosses to a focal point and draws the image on the back of your retina upside down. And that horizon line corresponds with the optical axis through the center of your lens, through the center of the aperture of your eye. And you have a resolution limit of what's about 0.02 degrees of arc width. Anything smaller than that, you can't resolve. So that's your diffraction limit of your own vision if you're looking through a clean vacuum, absent of weather effects, terrain undulations, water undulations, absent of crap getting in the way with like volcanic ash and pollution, and so on.
Yeah, nice.
Absent of Rayleigh scattering.
In this spreadsheet, is the radius? Are you working this out as part of the equation of like how did you work out the radius?
I took what NASA claims the radius of Earth is. You know what's interesting? Check this out on my spreadsheet. Horizon distance of 3 miles for roughly a 6-foot observer. The horizon dip angle is negative 0.02 degrees. That's the same as the diffraction limit of your vision on a flat Earth, which means a 6-foot man would be unresolvable whether it's a globe or a flat Earth.
I'm so glad you brought this up because this is what I was waiting to interject with. Should be.
Good. Please continue, Jedi. I have to work. I have to do some cooking.
No, you've done it. I didn't need to interrupt. I'm just happy.
But I feel like I'm conquering this Discord. I'm not gonna lie.
I've got another thing to show you sometime where I actually derived the radius of Earth from the diffraction limitations of your vision, showing that the globe could have been construed from optical phenomena on a flat Earth. I derived the radius from how your eyeball works.
Yeah, that's cool. For me, what I need for my equation is 2 different radius lengths. Like, I don't agree that when I'm on like one continent, there's only one measurement of elevation that matches. Every other measurement of elevation is a different radius, right? So in our experiment, we're identifying the equal radius, and we're using those. But the problem is that the radius.
Good enough.
The radius measurement for the geography from the first point is going to have a measurement, and then when we go over to the next continent, we shouldn't use the previous radius measurement. We should now remeasure the radius.
The thing is, we're doing these observations generally over water, right? Because we have, that's why these are done over water, because you don't really. I mean,
we just
the elevation of the water. Yeah, you do have to take the elevation of the water into account, but it's such a small difference, right? Like this is 4,200 feet above sea level. It only changes the radius to 3959.6. So the drop over 21 miles, it changes by such a small amount.
Like in that moment, maybe if there was like a tsunami or something, we'd be like, oh shit, we need to account for like another 40 feet. Like, okay, but this is a bit. We shouldn't do it in extreme
let's
conditions.
Not do these during tsunamis.
Right, but because it's going to throw off the measurement of radius even more. The point is we don't have an accurate measurement of radius at all
Not enough to account for the missing curvature, bro. It's just a code.
No, I want to help solve the curvature argument, but I'm saying one of the parameters we need is the full variability of radius across the surface of the Earth. But we are just supposing that it has a constant value, which is incorrect, right? Because we have elevation, right? So we have to we just do radius plus elevation equals total height, like a total radius. But then that doesn't account for what we now want to look for in the surface, like a curvature, right?
I don't think I understand what you're asking. It almost sounds like you're asking for the geoid model, EGM 96.
I think he's just saying to make it perfectly accurate, we need to take the elevation of the location into account, readjust the radius value slightly, and then do the math based off the adjusted radius value. But what I'm saying is...
No, we don't.
We don't?
The radius of Earth averages out. Like, we're testing to see... But WGS 84 is a valid curvature proclamation for Earth.
Right, but what I'm saying is if you have a 21-mile lake that's at 4,200 foot elevation, it's a greater radius value than at sea level.
Oh, I see. Okay, I missed that part. Yeah, dude, come on, that's barely nothing.
That's right, it's minimal.
It's nothing, yeah. It's not worth taking into account, really.
That's what I mean. It's not
Luke, here's my question.
Not account for all that missing curvature.
Go ahead, Matthew.
Luke, why do you care if... so the radius is 3959, but if you add 500 feet to it, then it's 3959.1. Which is hardly any difference. So that's why nobody takes into account the elevation.
Yeah, I was just saying for an accurate calculation, we would need accurate radius measurements from the points of reference. Right. So
what's your significant digits? How many significant digits do you think matter?
Every digit, obviously, but I just identified quickly that the elevation would matter, but we're just assuming that it doesn't.
Well,
it sounds like you're asking for millimeter accuracy, dude.
It does. And if you've got a way to measure the claimed radius.
So, Luke, we're not assuming that it doesn't matter. We're quantifying how much it matters, which is hardly worth taking into account. So, like I said, 500 feet increase in elevation would only increase the radius by 0.1 miles.
I heard you said
already begging the question with you enough.
I know. Okay, let me just respond. Right, I heard you the first time. If we don't account for the incorrect, like the possibility of an incorrect measurement, then what are we actually measuring?
That's accounted for in geodetic surveying. I brought up the name Helmert several times. He produced a gravimetric model of Earth that is based on how much mass there is warping gravity, but also altering the contour of Earth itself, where you have multiple gravity vectors pointing at different down locations instead of a common point of origin. It gets that complicated. And it's that complicated, and it also doesn't do anything significantly to alter your planar surveying measurements in the first place, which is why people don't use it for like plotting out cities and stuff.
Yeah, my argument with the accurate radius calculation is that the further, like with the local minima and local maxima reference, right, is that the further you go away from the Earth, the more you're going to see that curvature, right? But your argument is right now that if radius was infinity, we would still only see as far as the eye could see. right? Which is we're saying the same thing.
But do you really think it's going to make a difference to that 21-mile lake?
Our claim is we're off by orders of magnitude difference.
If I go high,
far beyond these meager calculations that you're proposing would alter the outcome. What we have observed are several orders of magnitude difference.
Yeah, I'm just saying, right? If I plug in the elevation and I plug in a high value for elevation, then I can see more, and it shows that there is no curvature, right? That's what we agree that.
Look, this observation is essentially essentially a horizon test as well as a curvature test.
Right.
So please have a look in the side chat again, right? So this is from close up. Well, okay, cool. Just have a look at the close up image, right, of that white tower. Now, the bottom 230 foot, right, of that tower should be obstructed behind the curvature of the Earth. I'm not even sure if the tower is even that high, to be honest. I have to double check that. But the bottom 230 foot should be obstructed behind the 2.74-mile horizon, right, if we go 21 miles away and make the observation. Right now, I'm going to post a second screenshot now when we've gone 21 miles away, right, and there isn't a 2.74-mile horizon and there isn't anything obstructed of that white tower that we can see there.
Yeah, DJ, I appreciate your speaking to the whole room as well as me. We did this yesterday with the oil rigs, and I don't really want to engage with something that we just don't have an understanding with. I don't understand what you're saying.
Bro, it's the equivalent of you saying,
you're talking to me, and I'm
talking to you, and I'm saying it's the equivalent of you saying to me, it's $20.01, and I'm giving you a $20 note, and you're saying, no, $20.01, please.
Yeah, maybe that's a good analogy if I'm not accepting what he's saying, but I'm not saying that. I'm just saying, I'm sorry, I don't understand what you're saying. Whether it's $20 or $20 and a cent or whatever.
Okay, so if the Earth was a globe, right, the horizon would have to be at 2.74 miles from a 5-foot observer height.
Yeah, no, I heard all this stuff, right? I'm trying to do the equation in the background.
I'm just trying to gauge. No, look, I appreciate you coming back, right? I appreciate like the good faith conversation today. I just want to let me just go 30 seconds. I'll go through it. Tell me which bit you get stuck at. Right, so you understand the horizon distance.
Yeah, I know. I heard I heard everything you say. You're saying I shouldn't be able to see the tower, but I can. Why can I see the tower? And I'm like, okay, let me try to work this out. And you just keep asking me the same question. I'm just saying, like, I need the radius equations in order to tell you, like, why. Yeah, I know.
3959.6 is the radius from 4,200 foot elevation above sea level. Right.
Yeah, that's not an equation. That's just numbers. That's not a formula.
You can use Pythagorean theorem. It's not hard. You can use my spreadsheet to work it out. Listen, if I can interject real quick.
Yeah, I'm trying to do that.
Gaussian refraction. Remember when I was talking to you about Gaussian refraction that increases Earth's radius by 13% to explain why they could see things farther. This means that 1 foot observer height off the ground, when you work out the math, the distance to the geometric horizon is 1.225 miles. If you add 13% to Earth's radius, from that same height, it extends the horizon from 1.22 to 1.32 miles.
Yep, lots of numbers, man. Thanks.
All right, so the question becomes, how consequential is this when we have horizon distances that are visible from 1 foot off the ground that are beyond 9 or 10 miles, 11? We're talking orders of magnitude different than any meager rounding of decimal numbers is going to matter. We're operating at such scale and distance where we do not need to be as precise as you think we do.
Yeah, I know. Like, we already agree that our eyes can see the sun, and the sun's like fucking far away, man. So.
Yeah, you're just seeing a light, though, right? So let's not get back to the sun. Like, let's just stick with this really quickly, right? So the difference is, right, between a 3959 mile radius and a 3959.6 mile radius, right, 0.015%. It's such a small amount that you
sure.
Well, hold on, let me finish. Right, so instead of 1.225 times the square root of the observer's height in feet, just add 0.0015 to the 1.225. I think, or add that tiny amount to the n number. It's such a small amount.
Yeah, and I got this little picture here. So like this difference is you're talking about like the height, the average height. Yeah.
The average.
Oh, you can't see. It says 8 kilometers. It says like the measurements on the left, but it's because it's PNG.
Which are you looking at?
The sea level height is averagely 8 kilometers difference, or something.
Oh, you're talking about because they claim that the Earth is oblate spheroid.
Well, well, you could draw it flat if you wanted to, but the point is that the average depth of the ocean is about 8 kilometers.
It's something like 10 to 20 kilometers fatter at the equator, according to the Glob, right? So even if we granted you that, it's such a tiny bit different, right? You wouldn't have to even take that into.
But this is just an average of the whole Earth, right? So it's 8 kilometers in depth is the ocean generally. Like obviously, you go to some places it's not 8 kilometers deep, and you go to other places it's further than 8 kilometers deep. That's what an average is, yeah. Of whether it's flat or globe.
I'm not sure.
Okay. Wait, you're not sure on how deep it is, or you're not sure on what an average is?
It sounds like your tangents are inconsequential.
Yeah, look, I know exactly what you're saying. I don't know the average depth of the ocean. That's all.
Okay, no worries. Do you think it matters how much water's in the ocean?
No, all you need to worry about is this is the claimed radius is 3959, right? If you want to adjust for the slightest difference due to the Earth claimed to be an oblate spheroid, right? It's insignificant when you're making an observation over 21 miles, like I'm presenting right now. You can work it out. I mean, all you're going to do is change the horizon distance by the tiniest little bit. It's not going to.
Yeah, I think what I need to do is
not going to account for the distances we're seeing.
Yeah. So what you have is like a 0.02% difference, right? Taking the elevation into account and taking the oblate spheroid into account, where we have like over 1,000.
Yes. Okay, great, nice.
How we can see.
Yeah, there is a big difference, right? Oh, sorry, not a big difference. There is a small difference or an insignificant difference, right? But there is a difference.
Yes.
Nice. Okay, great. Because like even on like the flat Earth, right? Like this difference, like it wouldn't matter. But on the sphere, it actually is incredibly
mathematically. Like this doesn't
matter for the globe.
Yeah.
If it wasn't like a sphere, we wouldn't care about like how deep shit was.
Yeah. So look, if you should have 230 foot obstructed at sea level, right, and you should have 229.5 foot obstructed at this elevation. Right, that doesn't really make a difference.
Why are we adding obstruction?
Okay, so the tower that I was talking about should be obstructed by 230 feet if the Earth was a globe.
By this approximation equation, yeah.
Yeah, so if you take into consideration the height above sea level and the oblate spheroid claim, right, then it would just alter it ever so slightly. But in reality, there's zero obstruction of the tower.
Okay, can I ask my north to south question now?
Yeah, I'm going to go on mute because I got some work to do. But yeah, go ahead.
Oh,
go ahead. We're all listening. Someone will answer you. I mean,
no, it was for. I guess.
Or you can just respond to the fact that there's no obstruction.
I already conceded that I don't understand what he means when he says like we don't like we see what we see, but we expect something else. I'm like, what do you mean? Like we see what we're seeing right now, and he's like, yeah,
Well,
there's no.
If you're looking at a soccer ball, can you see around it the other side?
No, that's not how dimensions work.
So if you're looking out in the ocean, you can't look around the globe and see things that should be covered by the curvature. The same way if you're looking at a soccer ball.
Yeah, because there's dimension and there's actually dimensions to the
right.
Yeah.
But when you actually do long distance viewing, there is no obstruction. It just keeps going.
Well, no, I did actually say that earlier. Like there is problems because we can't stand on the highest two mountains and see each other. Right, there's lots of problems actually. Like if we take all the obstruction away, like there's actually still a problem because we still have that drop off over distance called the horizon. But it's difficult because the horizon's a relative point of reference. So
okay, so if you take out the mountains and you're just doing it on the ocean,
the horizon's right there. You don't have to observe it. That's the point.
Does anyone understand what he's saying? I don't get it.
Well, someone just tried to interrupt me and say like it's relative to the observer height, and it's just like yeah, it is, but like the horizon's still there. Like it doesn't.
No, it's okay. So in the observation I presented, there's no horizon there, right? On a globe, there has to be a horizon at 2.7 miles, and the bottom 230 foot of the White Tower has to be obstructed behind the curvature of the Earth, right? Due to the equivalent 23-story building of water that's blocking it. If the Earth is a globe, right? So this observation is impossible on a globe. That's the point of it. And it's not only slightly impossible, right? It's magnitudes and then on top of the observation, we have the guys pointing lasers at each other from that 21-mile distance. And not only can we... Yeah.
Sorry, man. I thought you said you were going to work. Like I was waiting to ask my question. Sorry.
Okay, man. All right.
Or you can just respond that we see too far, and there's no curvature blocking our view.
I did just respond to that, Ancient Traveler.
So you agree with it?
Yeah, we've already explored the problem where if we stand on the highest two mountains on the Earth...
Well, I don't understand why that's a problem when you're out on the ocean. Why are you talking about mountains?
Because 40 minutes past the hour, infrared, high-altitude observations, seeing further than where the globe should and curvature exists.
I'm sorry, I just checked those, right? The horizon, right, we just try to tangent away to the horizon, right? Because the horizon exists relative to the height of the observer, as someone cleverly said. But yeah, the horizon is there, always, right? And so it's relative to how high you are, because that's how vision works.
Right. 1 foot observer's height, you're going to see a certain distance before curvature starts to block your view.
Yeah, that's why when we go up in the air, we can see the two tallest mountains. But when we're on one of the
but when we stay at 1 foot observer's height, we can see further than we're supposed to.
If we're on the tallest place on the Earth, we should be able to see all of Earth. That's
what
until the horizon.
If you're at 1 foot observer's height, you shouldn't be able to see 30 miles. But we do.
No, you're claiming something in an inverse way. I'm saying something, I'm asserting something, and you're trying to pose a negative claim.
No, you're being deliberately obtuse.
I am saying if you stand on the highest mountain and you look as far as you can see, you will not see the second.
And we're saying that if the Earth was of a specific dimension, then from 1 foot or 6 foot or whatever above a body of water, there should be a horizon at a specific distance. And we're giving you your little bit of allowance for a little bit of a lateness.
What you're asserting. Right. Okay, you're trying to say that I'm asserting globe dimensions, right?
You don't have to. It's been done for us.
No, I'm not doing that. Right? We're trying to solve the curvature.
We are.
When I say we, I mean the scientific community. When you say we, you mean Discord Deluluism, okay?
No. This is right. I'm showing you real-world observations, right? All you're doing,
DJ. I'm trying to speak to these people, and you keep interrupting, man.
Yeah, but look, dude. I showed you a presentation, and it's like you've got a mental block going on, and you don't seem to be able to get the problem.
Okay, you're just being obtuse. Can you be engaging?
Okay.
I will give you Earth's radius of 4,620 miles. That's 17% bigger, expanding the surface area.
Braddock, we've already determined that the relative radius is more important than an approximation, right?
No, it's not. We did not determine that. You did not substantiate your values.
Okay, I don't.
This requires you substantiating significant digits.
An equation. The higher the elevation, the more horizon you're going to see.
Yeah, you need to substantiate that amount as being relevant or justified. When we have observations that are orders of magnitude beyond where Earth's claimed radius is supposed to be for the horizon. You know what an order of magnitude is? 10x. We have 2 orders of magnitude.
You're talking about radius.
Yeah.
The radius your whole heliocentric system.
I know that you guys get a kick out of this, right? You get some entertainment value and you monetize this shit.
We don't monetize anything, dude.
Yeah, shut the fuck up, man. It's on YouTube. Okay,
it's not being monetized.
It's on YouTube. I don't care. This is being monetized. That video I just had to watch. The DJ video
might be making money out of it.
On it, okay? The advert on DJ's video is
wasting my time talking to you right now is costing me money, right? I could be working right now.
Stop talking to me then, because you don't understand what a radius is.
We do.
We're broken.
Bro, come on, dude.
You can break shit, my guy. You're insufferable. All of you are insufferable, and you're trying to.
You spent 2.5 hours with us. We had a great conversation. Why are you ruining it now?
It's disgusting that you don't have any scientific. You don't have scientific discipline.
Really, we were talking about coordinate transforms earlier and Keplerian orbital elements. What are you even talking about? We're talking about waveform signal transformations, and you're accusing us of being a bunch of dumb, ignorant retards?
Braddock, I am referencing scientific equations and formula, and you.
Yeah, me too. I gave you a spreadsheet which is far beyond your ken, apparently, because you haven't figured out what it's presenting to you yet. Yeah, I gave you a spreadsheet which you don't understand. I devised those mathematics myself.
Yes, and I've already.
You are still struggling to come up how to use a Pythagorean theorem to derive Earth's radius.
Braddock,
that's like 10th grade math, bro.
Braddock, your spreadsheet is missing information. I've already highlighted that to you.
It's not missing information. It's got all the elements that you need to do what you want it to do. Go for it.
You're trying to frame me as I'm the villain here,
Dude,
right?
after all of the freaking math I just went over with you want to accuse me of not knowing what a fucking radius is? Like,
Okay,
you're just playing now.
man. Stop talking to yourself.
No,
bro.
you shut the fuck up, right? Your time's done here. Right? We just wasted all of that time going over all of this stuff with you. It made some great content. Thank you. It's not monetized anyway. Right? If you want to start spasticking out now, right, and making ridiculous claims, you can just fuck off, dude.
So look, I've posted for you in the side chat a citation from Washington State University and one from San Diego State University. Oh, sorry, University of Washington Department of Mathematics and San Diego State University regarding distance to the horizon. You know, it's not science, but is that scientific enough for you?
He's just in spaz mode now. He did the same thing yesterday, right? Yesterday, he just sat there for 30 minutes straight, leaving and joining. For 30 minutes straight. This dude is insane. It's an interesting way to handle getting absolutely owned in a discussion.
Yeah. The University of Washington says, so for all practical purposes, we can estimate the distance to the horizon using 1.22459. There's enough digits for you there, Luke? Square root of h, or perhaps even more simply as just 1.2 times the square root of h, which is the observer's height in feet, which gives the distance in miles when h is in feet, right? There's your equation. That seems to be good enough for them, but not good enough for poor old Luke on Discord talking to some flat earthers.
Yeah, so what's the distance to the horizon?
Oh, buddy, I'm not going to talk to you. You're just going to keep being condescending.
You can stay on mute then, buddy. You can stay on mute. Yeah. Right? Talking shit in the side chat isn't going to help you.
I gotta go. I'll be back in 20 minutes. I'm gonna go on Deafin.
Okay.